Inside a modern Pringles factory, production begins with raw agricultural materials arriving in bulk quantities. Potatoes used for this process are not standard table potatoes, but specially cultivated varieties selected for industrial processing. These potatoes are grown under controlled agricultural programs designed to produce consistent starch content, controlled moisture levels, and uniform cellular structure. These characteristics are essential because the final product relies on precision shaping, controlled cooking, and predictable mechanical behavior during forming and frying. Upon arrival at the factory, truckloads of potatoes are unloaded into receiving bays equipped with automated handling systems. Each shipment is logged, weighed, and assigned a batch identification code that will follow the raw material through every stage of production. This batch traceability ensures full accountability and allows precise tracking of material quality throughout the manufacturing process. The first stage of processing is inspection. Potatoes are conveyed through automated scanning systems that use cameras, lasers, and density sensors to detect defects such as internal rot, excessive moisture variation, or irregular size. Any potatoes that fail to meet strict quality specifications are automatically diverted and removed from the production stream. Only potatoes that meet uniform standards proceed to the washing stage. The approved potatoes enter large industrial washing drums where high-pressure water jets remove soil, stones, and surface contaminants. These drums rotate continuously, ensuring that each potato is thoroughly cleaned without damage to the flesh. The wash water is filtered and recycled through a closed-loop system to minimize water waste and maintain environmental efficiency. After washing, the potatoes move into high-speed peeling machines. These machines use abrasive surfaces that rotate at controlled speeds to remove the potato skins efficiently. Sensors monitor peel depth to minimize waste while ensuring complete removal of the outer skin. Any remaining imperfections, such as dark spots or irregularities, are detected by optical sorting systems and removed automatically. Once peeled, the potatoes are transferred into steam cooking chambers. In these chambers, controlled steam heat softens the potatoes and activates starches within the cells. This step is critical because it prepares the potatoes for conversion into a smooth, cohesive paste. Cooking temperatures and durations are precisely regulated to ensure uniform starch gelatinization across every batch. After steaming, the softened potatoes are fed into industrial mashers. These machines apply mechanical force to break the potatoes down into a fine, uniform paste. The consistency of this paste is continuously monitored using viscosity sensors and moisture analyzers. Any deviation triggers automatic adjustments in processing parameters. This potato paste forms the primary base material for Pringles dough. At this stage, additional ingredients are introduced. These typically include corn flour, rice flour, water, emulsifiers, and controlled amounts of seasoning compounds. The exact formulation is carefully calibrated to produce a dough with specific mechanical properties. The dough must be flexible enough to be shaped without tearing, strong enough to maintain structure during frying, and uniform enough to ensure consistent thickness. The ingredients are mixed in large industrial kneaders. These kneaders operate continuously, applying controlled pressure and motion to blend the materials evenly. Temperature sensors ensure the dough remains within an optimal range to prevent premature starch breakdown or moisture loss. The mixing process continues until the dough reaches a uniform, elastic consistency suitable for sheet forming. Once mixed, the dough is fed into rolling systems that compress it into thin, continuous sheets. These sheets are significantly thinner than traditional potato slices. Precision rollers control thickness down to microns, ensuring every sheet is identical across the entire production line. Thickness uniformity is essential for consistent cooking, texture, and structural performance. The rolled dough sheets then move into cutting stations equipped with high-precision stamping tools. These tools cut the sheets into oval shapes, each one identical in size and mass. Any excess dough from the cutting process is collected and recycled back into the mixing system, minimizing waste. The oval dough pieces are transferred to curved molds that give Pringles their distinctive saddle shape. These molds are engineered to exact specifications, ensuring every chip has the same curvature, radius, and structural geometry. The curved shape improves stacking stability and mechanical strength during handling and packaging. As the dough pieces settle into the molds, they are held in position briefly to allow the shape to stabilize. From here, they move directly into the cooking stage. Unlike traditional potato chips that are fully deep fried, Pringles use a controlled hybrid process combining frying and baking. The shaped dough pieces enter oil-based frying systems where they are exposed to carefully controlled temperatures for a precise duration. The frying stage initiates moisture removal and begins forming the chip's crisp structure. Immediately following frying, the chips pass into baking chambers where hot air circulation completes the dehydration process and finalizes texture. Throughout cooking, temperature sensors, airflow monitors, and timing controls ensure each chip experiences identical conditions. This ensures consistent color, texture, and strength across millions of units produced daily. Once cooked, the chips exit the ovens and enter cooling zones. Controlled airflow reduces temperature gradually to prevent cracking or warping. Cooling also prepares the surface for seasoning adhesion. While still slightly warm, the chips move into rotating seasoning drums. In these drums, measured quantities of powdered seasoning blends are applied evenly to the surface of each chip. Automated dosing systems control seasoning weight with high precision to ensure flavor consistency. The seasoned chips then pass through quality inspection systems. High-speed cameras and optical sensors detect defects such as cracks, discoloration, or irregular shapes. Defective chips are automatically removed from the line. Only chips that meet strict visual and structural standards continue to packaging. Approved chips move to the stacking stage. Robotic alignment systems position each chip precisely, stacking them into uniform columns. This alignment minimizes movement and breakage during packaging and transportation. The stacked columns are gently inserted into cylindrical cans. These cans are lined with moisture-resistant materials to preserve freshness. A metal base is sealed onto the bottom of each can, and the stacked chips are secured inside. Before sealing the top, nitrogen gas is injected into the can to displace oxygen. This controlled atmosphere prevents oxidation and extends shelf life. After nitrogen flushing, a plastic lid is applied to seal the can. Each sealed can is weighed, labeled, and scanned to verify accuracy. Cans that fall outside weight tolerances are automatically removed. Approved cans are grouped into multi-packs, boxed, and placed onto pallets. The pallets are transported to warehouse areas where inventory systems track their location and destination. From there, shipments are dispatched to distribution centers across the United States. Advanced logistics systems coordinate transportation schedules to ensure timely delivery to retail outlets. Throughout the entire factory process, sanitation protocols are strictly enforced. Equipment is cleaned regularly using automated cleaning in-place systems. Air filtration maintains clean environments in critical processing zones. Every batch remains fully traceable from raw potatoes to finished product. This manufacturing process operates continuously, producing tens of thousands of chips per minute with minimal human intervention. Automation, precision engineering, and real-time monitoring systems work together to maintain efficiency, safety, and consistency. Inside a modern Pringles factory, every step is controlled, measured, and optimized. From raw agricultural materials to sealed cans ready for distribution, the entire process is designed to deliver uniformity, structural integrity, and high-volume output at industrial scale. We hope you enjoyed this Quantivox tech video. If you found it interesting, don't forget to like, share, and leave your thoughts in the comments. Your support helps us bring more fascinating stories and insights. See you in the next amazing video.